Hello, so my name is Michael Lebenek. I'm a senior developer advocate with AWS Mobile, mostly with focusing on JavaScript development. Specifically, we'll be talking about Ionic and React applications using AWS Mobile Hub. So first, I'm going to talk a little bit about just the kind of some of the key differences around native versus hybrid mobile applications. So at a very high level, native apps are platform specific. So Android, iOS, built to run on the specific hardware and only on the specific hardware. They're built with compiled languages, so on the iOS side, Objective-C, on the Android side with Java. And they have access to device hardware, native access to device hardware like camera and hard drive, stuff like that. They also utilize specifically the platform frameworks. So with iOS, you have things like Swift, Objective-C, and with Android, you have the Android framework and some other higher level frameworks that have come about recently. So on the hybrid side, these are generally cross-platform. A lot of time with scripting and compiled languages like JavaScript. There's usually to access the device hardware, there's plugins or native modules. So with Ionic, it uses Cordova, which is an open source product by Apache that allows plugin development, and it allows you to access device hardware writing JavaScript, and you can write plugins using the native framework. So you could write a native plugin with Java for Android, and with iOS, you'd write it with Objective-C. On the React Native side, they do have native modules as well, similarly. And generally, you're writing with web frameworks with hybrid apps. So with Ionic and Cordova, you're going to be writing JavaScript, or more recently, TypeScript. And with React and React Native, JavaScript with JSX and also TypeScript. So some of the similar aspects between native and hybrid, they both are going to compile to a binary distribution for the App Store. So on the Android side, it's going to compile to an APK, and with things like Ionic and Cordova, it's going to run in a web view. With React Native, it's a little different. It's going to actually be compiled to a native app, and it's actually going to run native components. But either way, they're both compiling to a native binary that's going to get submitted to the App Store. There's an exception here with PWAs. So PWAs are progressive web apps. These are just web applications. So websites, sometimes referred to as the mobile web, and they do not compile to a binary. They just sit on a server and they run just like a website and are able to be added to the home screen and installed in the device. And we'll talk a little bit more about those as well. So JavaScript execution is done with hybrid apps and done in a platform-specific way. So with iOS, it's using a JS Core library, and with Android, a V8. So these are the execution environments that actually execute the JavaScript on the platform's device. So first, let's talk a little bit about Ionic. Ionic is a UI framework that is developed with JavaScript or TypeScript and allows you to build UI components in a web view. So these run HTML, CSS, and JavaScript, TypeScript as well. And the native portion is run by Cordova, and that's the Apache product that runs the native, that you can write the native plugins for. The Ionic app will run in a web view, so that's essentially a Chrome browser or an iOS Safari browser that's running a native app, and it's running in a web view, and it's running essentially a website and communicating with the native platform via some sort of bridge, JavaScript bridge. Ionic, again, is just a UI framework, and it's built on Cordova, and it uses AngularJS for its programming framework. And with Ionic and Cordova or any JavaScript, you can use AWS Amplify to talk with the backend AWS environment in a declarative way. So let's talk a little bit about React Native. It's a little different. It does compile to a native app, but it also allows you to write JavaScript in something called JSX, which is an implementation of XML within JavaScript, and it allows you to write the views within the JavaScript files. It uses native components instead of web components, so you can write regular JavaScript components that they provide as the React Native framework, or you can write native platform-specific components like list views and things like that. So it does use the same fundamental UI building blocks in that sense as iOS and Android apps do. And AWS Amplify has a React Native implementation that allows you to write declarative syntax and use out-of-the-box components for login, S3 uploads, and things like this. So progressive web apps have three distinct aspects to it. There's a service worker, which runs background tasks, allows things like push notifications, specifically web push, which is different from things like Firebase messaging and iOS messaging. This is specifically a web implementation, a web framework that allows notifications to a browser web application. They are discoverable and installable. So discoverable in the sense where they can have search engine optimization done to them and found via search engines, and then installed via the add to home screen on your mobile device. So there's no app store involved here. They're also network agnostic. So one of the benefits, obviously, of a native app is the ability to work with the network connection and the ability to run offline. So with the PWA, you can do this as well. The service worker acts as a network proxy and can intercept requests and either cache things and run them offline, or fetch requests and run them offline and store them in things like IndexedDB. And you can also use AWS Amplify to write these progressive web apps the same you would write, so for example, a React app or an Angular app, and we'll show an example of that in a little while. So the three distinct aspects of a progressive web app are the application shell, the service worker, and storage and caching. So the application shell is your app, as the HTML, the CSS, the JavaScript, and this will get cached on the local device when the web application is installed or added to home screen. The service worker is running in the background, so you could think of this similarly to something like an Android service that's running in the background, and it's handling accepting push requests and handling network requests. If things are offline, it will cache things and provide the application shell with data from a cached database like IndexedDB, and the storage and cache. So service workers can interact with IndexedDB, and they contain IndexedDB APIs natively, so you don't actually have to include anything. But there are higher level frameworks like local storage and things that make this a little easier to work with. And you can also interact with local storage and cache in the browser. So the application shell is bundled up HTML, CSS, and JavaScript. This is cached immediately on the device and basically always loaded from the device to provide a good user experience and be more network agnostic. You can also set flags and do things like you would generally do on a CDN with different file names to pull and check from the network and pull new versions of the UI and cache it and then load it. So it's generally downloaded once and immediately cached and loaded from cache, and this provides a good user experience for when your installed PWA opens. So the service worker is a programmable network proxy. One thing with the service worker is it cannot access the document object model, so you can't get elements on the DOM or anything like that like you would in your JavaScript framework. It does respond to messages via standard post message event, so you can interact with it and send messages to and from. And again, it has access to native IndexedDB APIs. Most modern browsers support it. Safari is currently the only one not supporting it, and that is a work in progress, and that link there will give you a status table of anything that's where those browsers are at. So in terms of storage, there is a local storage and IndexedDB generally for storing data and working with data. So local storage is a blocking and a synchronous storage system, whereas IndexedDB is a more transactional database, and APIs are available natively in the service worker. The only caveat to something like IndexedDB is it can be fairly complex to work with, but there are wrappers available. So local storage is one I have an example of after this that I could get into. It's a pretty popular one and works pretty well with interacting with IndexedDB APIs. It gives you a fairly similar API to local storage, get, put, stuff like that, to get and put and set data within the IndexedDB. So within AWS, we have starter apps for these for various types of mobile applications, hybrid, native, and as well as web and PWA. More coming in that category as well. So these are available on GitHub, and I'll go through some of these after the presentation. In terms of native apps, we have React Native, iOS, Android, and Xamarin. Hybrid apps, we do have an Ionic starter. Ionic themselves also have an AWS template that you can launch via their CLI. That's a starter for AWS, which in the background, Ionic also uses Cordova. And with web and PWA, we have a React sample, Ember.js, and we're also developing Angular and a Vue sample. And these starter apps can be found directly on GitHub on the AWS and AWS Labs GitHubs, as well as if you go into AWS Mobile Hub, which I'll go through, you can click on these with a one-click deployment and launch these from AWS Mobile Hub as well. And this will set up your entire backend for you. So I'm going to talk a little bit more about AWS Amplify and the mobile CLI. So diving a little deeper into development of these applications and the frameworks that we provide and the support we provide with AWS Mobile Hub. So I'm going to talk a little bit more about AWS Amplify. AWS Amplify is a JavaScript library for front-end and mobile application development. It's written in TypeScript, and it provides JavaScript and JavaScript frameworks with a declarative interface across different categories. So it provides things like authentication and analytics, API, storage, and cache. And it provides these in a categorical way so that you can interact with something like authentication in a very simple declarative way. So things like sign in, sign up, and it will have a cascading service approach, whereas if you're storing an image, it will prefer things like S3 over API Gateway. And it provides a very simple way to interact with these services. And it is open source and available on GitHub. So the AWS Mobile CLI is a CLI tool that allows you to bootstrap new and existing projects with single commands. So you can essentially do the majority of the things you can do in AWS Mobile Hub console with the CLI. And it'll also allow you to easily enable and disable services and integrate them with AWS Amplify. So you can publish changes to Amazon S3 for hosting of your PWA or web application with a single command. So instant hosting for web and mobile apps is a pretty key feature and allows you to prototype and iterate quickly on mobile applications or PWAs. And the CLI is also open source under Apache license. So this is a quick example of AWS Amplify and the mobile CLI. You simply install it with NPM. You can use something like create React app to create a simple web application. Once you do that, you can run a AWS mobile init command, and that will essentially set up a brand new AWS Mobile Hub project with analytics enabled by default, and you could import the AWS Amplify library. It will also download the AWS exports file from Mobile Hub for you, and you can configure the Amplify library with that config file. That off the bat is basically all you need to do to start programming things like authentication or API calls. You can enable these features more with the CLI, and these 3 lines of code here, if you were to write those with some of the lower level SDKs, would be potentially 50 to 100 lines of code condensed into 2 or 3 to get everything bootstrapped and ready to go. So I'm going to talk a little bit more specifically about React and React Native in terms of using AWS Amplify to develop these and AWS Mobile Hub. So we provide out-of-the-box React HOCs. This is for a higher-order component for React and React Native that allow you to wrap your application and provide default UIs that are scaffolded for things like authentication, sign up, forgot password, MFA, SMS, and it also manages your credentials via the local storage systems. So you can import these, and then you can use them with the default HOC methods with your application, and this will give you an entire UI experience that you can customize if you want or not. There's also, underneath that, the canned authenticator component that you can import into your apps. So if you import this authenticator component, It also provides a scaffolded UI, and it also allows you to customize it even further by providing only certain components and also listening to state changes. So logged in, logged out, things like this you could listen to on the authenticator component and show various actions. So as you can see, it just kind of condenses everything down to in a declarative syntax and allows you to just use these canned components. So the authenticator also provides you the ability to customize these things with other components. So if you only wanted to use the authenticator for sign in or sign up, you can stack these up and again listen to the state change events on the authenticator. We also provide a photo picker. So this is again a canned UI component that you can import. It provides a scaffolded UI, and it provides all the functionality underneath it to upload S3 images. And these can be public, these can be private based on your users and your whole setup. So you don't have to just do public uploads. You can also do per user private uploads with this with a single line of code. You can interact with state events and progress, and also this will manage the credentialing for you. If you say this is private, it's going to use the currently logged in user's Cognito identity ID and as the prefix for the Amazon S3 bucket. There's also an S3 album component that will manage multiple photos and more of an album view within your application. So you just provide that as a single line and a path, and you can also include the picker as part of the canned component to allow uploading as well. There's a few even lower levels, so if you just want to display an S3 image or you want to display text from S3, you can just use these declarative components to do that. So a little bit more on the AWS Mobile CLI. Again, it's part of NPM, so you just do a global install of the AWS Mobile CLI. It is open source on GitHub, and it produces your entire AWS backend. If you're just doing a simple app with analytics, this will be done in seconds. You can enable and disable features like sign-in or user auth or private user storage via the CLI as well. And you can also benefit from the AWS Mobile Publish command to publish your apps to S3 instantly without having to go into the console at all. Some of the features you can enable via the CLI: user sign-in using Amazon Cognito, user files, APIs using Amazon API Gateway. You can configure databases, NoSQL databases with Amazon DynamoDB, and you can also configure analytics using Amazon Pinpoint. The analytics feature is actually enabled by default. You can disable it if you want to, but it's going to automatically start tracking events like session events and signed in, sign out events automatically for you once you instantiate the Amplify library. So as far as hosting and streaming, you can publish your front end using one command, AWS Mobile Publish. That's going to push your built production application up to Amazon S3. It'll automatically do that. You don't have to do anything, and it's also automatically going to create a CDN with Amazon CloudFront for you as well. So I'm going to get into the starter apps that we have available. So we do have starter apps for the various JavaScript frameworks available that we maintain. We have a React Native starter that is a pet tracker app that's going to use an AWS Mobile Hub backend with a NoSQL Amazon DynamoDB table. It's going to use Amazon API Gateway with AWS Lambda as a proxy to interact with Amazon DynamoDB, and Amazon Cognito for your user authentication and authorization. It's going to also do private user image storage within Amazon S3, and that's all going to be configured via AWS Mobile Hub. We also have a React sample, so this is a standard web application that could be also used as a PWA. So it uses Amazon CloudFront and S3 for the web hosting portion of it, Amazon Cognito for the authentication, and AWS Lambda as a proxy for Amazon API Gateway. And this is also using, as well as the React Native example, the Express middleware within AWS Lambda to provide routes on the Lambda side. We also have a Ionic sample. So the Ionic sample similarly is more of a to-do app that has a similar type of architecture. It's going to use, again, Amazon Cognito for the authorization and the proxy with AWS Lambda for the CRUD operations. Ionic framework team also has a starter within their CLI that you can use. So if you do, when you bootstrap a new Ionic app, you can give it an AWS parameter on the CLI command, and it will bootstrap a new AWS Mobile Hub project that you can then import into AWS Mobile Hub. So now that we're done with the slides here, I'm just going to jump into a little bit of a few demos to go through some of the starter kits in AWS Mobile Hub. So in terms of starter apps, I have the React Native starter here and the AWS Mobile React sample, a web app, and a React Native app. You can get these directly from AWS Mobile Hub. If you scroll down to the bottom, you'll see starter kit with React Native, React, JavaScript, and then there's also an Android sample. So if you click on one of these, you can click Start, and it's going to run through a bunch of steps for you here. It's going to provision your back end, and then it's going to instruct you to run the CLI as well. So I already did that portion, so we don't have to wait for the back end to spin up. Should generally only takes a couple minutes, but just so we can move quickly here, I'll show you what that looks like. So the React sample here is going to set up a web app for you. It's also going to give you the ability to run performance tests via device farm, so you can see things like how long your web application took to paint on the screen, stuff like that. You can also run those tests from the CLI as well. And it's going to enable user sign-in, NoSQL database with Amazon DynamoDB, an API with Amazon API Gateway and an AWS Lambda proxy, and hosting and streaming with Amazon S3. So similarly with the React Native sample, you'll get a similar backend. Let me just run this here. So once you clone these from GitHub, you'll end up with a folder structure like this. You have a client and a backend directory. And if you run an AWS Mobile init command on here, you'll get an AWS Mobile JS folder. This is going to contain your backend and your cloud API, and it's going to have an app.js and an index.js file, which is running the Express proxy for AWS Lambda. So this allows you to run an entire Express server serverlessly on AWS Lambda. And then you have your CRUD operations in the app file, which is just a standard Express setup here, interacting with DynamoDB. So the AWS Mobile JS file gives you this backend, and then what you could do is AWS Mobile features after that, and you'll, client, Mobile features, and you'll get the ability to enable or disable features via the CLI like this. And then you could do an AWS Mobile push. You could push changes up. If you edit your Lambda code here, you can push those up and for testing or deployment. You can also do an AWS Mobile pull to pull changes from the back end if you did the back end changes via the console or anything like that. And what that's essentially going to do is pull down your AWS config file and update it for you. So it'll connect to your AWS Mobile project and pull down the AWS exports.js file. And it's going to look something like this. So this file is auto-generated, so you never have to edit it or anything. It just enables and all the features that are enabled in your back end for your application. So AWS Amplify is going to use this file to know what to interact with on the back end, but you generally can just use the CLI or even the AWS Mobile Hub console to generate these files. So let's take a quick look at what this looks like, and specifically with React Native in this example. So once I have my application up and running, let's run this so we can see what the front end of this looks like. So I'll take a bit to compile there. So generally to interact with AWS Amplify, as you saw in the slides, is you're going to import this Amplify library here, and you're going to configure it. So the configuration is pulled from the AWS exports file, and it's configured, and now you can interact with things like API gateway and things like that out of the box. We'll take a look at what that looks like in a minute. So for this is the React Native Starter. So it comes bootstrapped with a lot of stuff, a full-blown application that has a drawer navigation, routing, all built in with the back end. So to give you an example of what something like the API perhaps looks like for calling REST APIs with AWS Amplify, you can import API from AWS Amplify, in this case React Native, and then you can interact with the API via simple get and put commands like this. So this will run essentially an asynchronous operation on a post event, items/pets, which is what's part of my back end, and it's going to send this body up to the API. So without doing anything at all, just running that one import statement, I'm able to run entire REST API requests within my React Native application. So this is what the app looks like when you run it. It's pretty simple. It has a bootstrap customized authentication with forgot password and sign up and sign in. So you can create new users, you can sign in with existing users. I'm going to create a new user. And once you sign in with your credentials, it's actually going to send an MFA code over to you via SMS, so you can enter that code. And then now I'm going to have a user created within Amazon Cognito. Test, I think. Oops. So again, on sign in, I'm going to get a SMS code texted to me. And now I'm in my pet tracker app. So all those features as far as signing in, signing up, authenticating, forgot password, MFA, single lines of code with AWS Amplify to be able to do those things, or none at all if you don't customize the UI heavily. So within the pet tracker, we'll now be able to add pets. Let's take a look at the console here. You'll also see things like AMA events, which are going to go to Amazon Pinpoint. You're going to see some console logs for logging in, any errors, so user does not exist errors. You'll see all these things, which is handy for when you're developing your application. So when you add a new pet, you can upload a photo. This is going to go to Amazon S3. Enter a name, a date, and the gender. Pet. So that's going to do an API request via Amazon API Gateway. You can see down here, and it's going to reload my pets as well. Now I can view the details of this pet, load the image from S3. So it's a pretty, it gives you a lot of functionality out of the box to be able to play around with in terms of React Native. This will also run the same on Android as well. So it's a pretty powerful sample app that you can get started, in a few minutes on AWS. Let's click this out. So let's take a look quickly at what the React sample looks like. So the React sample is a web application. It has a restaurant ordering system, and it's also built using AWS Amplify. So let's take a look at that real quick. So if you remember from the React Native app, you'll start seeing a lot of similarities here. So this is the React Native app again, and then within the React app, you'll see basically the exact same thing. So import Amplify. In this case, we're also importing auth from AWS Amplify. We're also tracking the lifecycle of this React event. So we have a package, AWS Amplify React as well, which is going to provide those HOCs and other helper methods specifically for React. And we're also importing that configuration file that we got from AWS Mobile Hub via the AWS Mobile CLI. And again, we're configuring it with that file. So you'll see basically exactly the same thing here. This would be exactly the same thing in essentially any framework, is importing the file and configuring it. And you'll see here we're also listening to this auth change event. So that is using on a login card on auth change. We're listening to the authentication change. We're going to log in. And if there's a current session, it's going to automatically log me in. So let's take a look at what that looks like. So while that's starting, let's take a look at what my Mobile Hub project looks like over here. It's going to have my features enabled, which were actually enabled via the CLI. It's going to have my app here and my ability to view test results as well. So this is an actual screenshot of the app and a test results from different devices that you can see right in the browser. So you can, when you do an AWS Mobile as well, when you use the CLI, it's going to run these tests for you automatically. So let's take a look at this app. Okay. So this is what the application looks like. It's going to give a similar authentication mechanism where you can log in, log out, and it's also going to handle the MFA for you as well. You fill out this form, and it's going to do basically the exact same thing, send you an authentication code, and allow you to log in, create account. So when I register, it's going to send me an SMS code. From that, and now we can log in. So on login, we get another MFA. And a lot of this is really just, for example, these steps can be fairly cumbersome, but it'll allow you to kind of see, how the application works and how to use MFA and things like that. You could also resend, validate. So now within the app, it's a simple example as a restaurants app, so you can insert restaurants into the database, which is Amazon DynamoDB, and then you can list them out. So now you see you have a bunch of restaurants here. You can click on one, you can place an order. Again, this is all just examples of using the functionality. Then you can go over to orders. You can see the order I just placed. You can go into the AWS backend and look at DynamoDB and see what these look like, and you also get some console logs here. But just quickly, these are all using React to get these methods within the provided AWS mobile sample. So let's close these out real quick. So real quick, let's go through a React app that's set up with some more of the features of AWS Amplify, so you can get an idea of how that works. So these examples and the way you interact with AWS Amplify will be the same for pretty much any platform you're using. So in this example, I have a simple setup with different components provided by AWS Amplify. There's a sign-in. This is the analytics, which is provided out of the box, and you can also interact with the analytics without being signed in. But once I do sign into here, you'll see a few more cards show up here. And you'll see things like MFA, sign-in, and stuff like that is really platform agnostic. So you could be doing these things on the web and in React Native, and the interface and the programming interface using AWS Amplify is going to be the same. So you'll see I have a bunch of other cards that showed up here. Let's take a look at what that kind of looks like. So in my app.js, you'll see I'm importing my components here, and again, I'm using the track lifecycle for React, and I'm configuring AWS Amplify with my AWS exports, same as all the other ones. And you also see that I'm not really switching any views or anything. This is a single page app, and it's showing and hiding items based on if I'm logged in or not. So I didn't have to refresh any pages or anything like that. And this is set up with different components for different cards, and I'm also listening for the auth event and showing those things. So you see if I refresh the page, I'll still be logged in, and my logged in state will be saved. So for example here, I'm just setting up a simple component, a login card, a user files card, API card, and these are all being sent in my AWS exports config file. And the reason for that is I'm using that as a configuration, and I'm also supporting federated login with Facebook. So in this, I'm just going to be using the authenticator component we talked about, sending it the federated info if I wanted to use that. And I'm also sending it a theme. So the theme is what allows me to customize this UI. And it's a JSX file that has some stuff that looks like CSS to be able to configure my theme. And these are canned. You can get them out of the AWS Amplify library, copy the default one, and just kind of mess with it. And then I'm listening to the state change event for the authentication change, and that's how I'm modifying the UI on the front page. So here's a user data storage. This is done with Amazon S3, and it uploads photos privately for users. And this is how I'm doing it. So I'm importing S3 image from AWS Amplify React, and I'm listening for an upload event, and I'm using a storage.put. I'm giving it the name and the file, and then I'm setting some state based on that. And then I'm also recording an analytics event once my file's been uploaded. So if you've ever done any development with the lower level SDKs, you'll sort of appreciate how few lines of code that is to upload a private image. So just upload one real quick here. So this will go into my S3 bucket with my user's prefix. It'll automatically show a preview there. And that's all done with this. A few lines of code. So messaging and analytics using Amazon Pinpoint. You can send custom events, you can send metrics to Amazon Pinpoint, and when you do, you can verify these. You'll see events, network events as they go up. You'll see things like session start that's happening in the background, session start, session stop if I put my browser in the background, or similarly with React Native or anything like that. You'll see these events going back and forth to Amazon Pinpoint. And this is the custom event that I just sent here. Pretty simple with the analytics, but can be pretty powerful way to track how your app's being used and very easily send custom events. So with CloudLogic, it's using Amazon API Gateway. And again, very similar declarative syntax, API from AWS Amplify, and then using a GET, this is mocked up to use the UI, so you could send a GET, post, put, and then similarly, it's just API, method, name, path, and then send your data. So this is using a backend that I configured with AWS Mobile. Let's take a look at that real quick. And this is just doing a simple CRUD operations on an Amazon DynamoDB table and returning the results. So it will also print these results out here for me. So you'll see my API call being made here. You'll see that it's also made in a private way, so these items are protected because it's automatically putting my user ID on them for me as a partition key. So now my items it's an entire, if you will, multi-user environment with Amazon DynamoDB, pretty simple, and I can send and receive and put objects and not have to worry about dealing with that multi-tenancy. So let's take a look at a PWA example using Ionic. Before I do that, let's look at the code. So the main things with the PWA, again, as we said, is the service worker. And the service worker in this example is using a local forage library, which is open source, and it's storing, pre-caching my UI elements, my JavaScript, my CSS, and it's logging some information. So with a service worker, you can attach to lifecycle events like install, activate, fetch for network requests, and these will run every time a network request is made. This will run every time your application is activated, and install will run if somebody did add to home screen and installed the application on their device. So with a fetch event, this is going to run on all network requests. So it gives a way to catch network requests, cache them, and do different things. So in this example, I'm catching network requests, and if I'm checking if it's a request to a specific service. So in terms of DynamoDB, I'm going to want to catch those and cache them and be able to run offline, essentially. So you'll see this is a pretty simple app. I was automatically logged in because I was logged in previously, so it caught my session, it automatically logged me in. So in this example, you'll see in the service worker tab, you have the ability to update on reload the service worker, and that's pretty important because the service worker will be running in the background, and if you don't have this cached, if you don't have this checked, any updates you make to the service worker won't be reloaded. So you want to make sure you have that checked if you're within development. And you can also emulate network connections, which is useful for service workers. You can check this box, update your UI, and set various things to happen when network connection is lost. And you can also emulate different types of network connections. You'll also be able to see your databases here. So you'll see local storage here. You'll see the Amazon Cognito SDK information being cached here, as well as whatever you're caching with your service worker. So in this example, I'm caching my DynamoDB items so that I could work with them offline. And I'm also caching some Cognito information, as well as some example information. So this really just looks like this. I'm listening to the fetch event, checking for the service, and I'm running the fetch, and then I'm also using local forage to just set the item based on key. Pretty simple stuff. And then you can also do things like queue failed requests up. So if you're running offline, you can queue those requests to be run when you're online, so you could run a true offline first functionality with the PWA. One other aspect of the PWA is the manifest file. So that's going to dictate sort of how your application is looking on the user's home screen, the icon and things like that. And also within your index.html file, they'll be specified for other platforms like iOS and Microsoft Windows. So finally, let's take a quick look at an end-to-end example using the AWS Mobile CLI, bootstrapping a new project. So I'm going to quickly just create a React app. So it will be the quickest way. React Native is a exactly similar process, except some of the steps take a little longer. So with create React app, I'm gonna create a quick demo app. And this is just an open source tool. You can get this by doing a npm install -g create React app, and it's just gonna create a plain React application with some functionality like auto reload and stuff like that bootstrapped for me. So now that that's done, I can cd into my React app. Let's see what it looks like. npm start. So this is without any AWS functionality. We're just going to have a plain React.js app. And this is going to have a source directory for my source, and then it'll also have some build functionality so I can build it. Let's take a look at here. So now let's create a new Mobile Hub project. Mobile init. So what this is going to do is ask me some questions. You'll see I had this folder was automatically created for me here, and it's going to ask me where's my project source directory, which is source, what's my build directory, which is going to be build. The defaults are more geared towards React right now and any standard sort of functionality. So a source directory, a build, sometimes you want to update that to something like dist. But in this example for React, it's going to be all the defaults. So now you'll see it created a bunch of stuff for me. I can also go into Mobile Hub and I would see that project created. We're going here. See, it was React demo app right here. It appended a timestamp for me there, and you'll see it had enabled messaging and analytics and hosting and streaming for me. So now, just with those few things done, I can do something like so now that I specified my build command too, I could do an AWS Mobile Publish, and what that's going to do is connect to my backend. You also see that it downloaded the AWS exports file for me here as well, which has my Cognito identity pools and my configuration for that backend that I just showed you in AWS Mobile Hub. So what this is actually doing is it's going to run my build command, which create React app setup for me. It's going to run this command for me. It's just going to run a build. It's going to create the build directory, and this is just React stuff, so it's going to create the build directory for me there. And then the AWS Mobile CLI will actually publish that up to S3 for me, and we'll also have the CloudFront distribution set up as well. So now it's creating the production build for me here, which is running the npm build script. You'll see I have a build directory now, and now it just opened up my default browser, and you can see I'm running on S3. So that's more what I was talking about in terms of instant web hosting. You don't have to run any CLI commands. You don't have to use the CLI, the AWS standard CLI as far as the S3 commands. You don't have to upload anything via the browser. One command and you're up and hosted on S3. Then you also see on the console, I had a few things logged out for me here. I have my application Amazon S3 URL, and I also have my CloudFront URL. So now I'm automatically hosted on S3 for development purposes, and I'm also going to be, once the propagation finishes for CloudFront, on CloudFront. So pretty powerful way to get up and running and prototype. So in terms of AWS Amplify as well, you'll see I do have my AWS exports file now, and I also have within my package JSON AWS Amplify included, and I didn't have to do any of that. So the AWS Mobile CLI had bootstrapped that stuff for me. Now I can go into here and do import Amplify from AWS Amplify. I can do import AWS exports from exports. So that's going to import from the exports file I imported. And then I'm going to say amplify.configure AWS exports. So now with those 3 lines of code, let's see what I get. So without doing anything at all, I'll have my AWS Mobile set up as far as analytics. So those analytics and Cognito identity information, if you go over the network tag here, you'll see I have some Cognito calls being made here for me. This is essentially creating using an unauthenticated role right now because I don't have user sign-in enabled. But you'll see I'm interacting with AWS now. I didn't have to do anything as far as getting credentials or temporary credentials. It's implemented using best practices in the background. So using Amazon STS to get temporary credentials through Amazon Cognito, these credentials will expire. I can use session management locally, all with those 3 lines of code. You also see I have an events method here. If you look at the payload, I have a session start event sent over to Amazon Pinpoint. So I don't have anything else enabled on this project. So if I go over to AWS Mobile Features, you'll see these aren't enabled. So say I enable user sign-in. Now I do an AWS Mobile push. Now what that's going to give me, it'll essentially update my AWS Mobile Hub backend. It's also going to update any APIs I might have enabled. And you'll be able to see those features enabled on the AWS Mobile Hub project as well. Here, and then once that finishes, we'll see now I have a user sign-in box here. And that implemented email and password for me with the defaults as far as multi-factor and minimum password length and password policy stuff is all set up and ready to go. So now that that's done, I can go into my React app, and I'll want to install the React package. I'm going to save it. And then once that's done, I'll be able to import, say, with HOC component. And I'll be able to wrap my app with that HOC component. Save that. And now you'll see I have a default sign-in screen. So with 1 line of code, I now have an entire authentication mechanism set up for me. And if you go ahead and try to log in, you'll see I got user does not exist. And I can go through and sign up and get my MFA code. Similar process you saw in the starter app, but it's completely bootstrapped for me. And you'll see it's set up in a responsive way as well. So this could be done with React Native, with React, with any JavaScript app, with any this particular HOC with any React app, and you could also import the let's take a look quickly. If I didn't want to use the HOC, you can also use the authenticator component and put that in your application. If you wanted to customize that authentication system a little more, you could do something like this. Save that. And you'll see now I'm not using HOC. It's not blocking my entire application. I just am using the standalone component and with the same functionality. So pretty powerful to get set up with something like authentication, since that tends to be a lot of work when using lower level SDKs or anything really. So thanks for joining the webinar, and we look forward to helping you develop some awesome mobile applications.